Hello everyone, True Zero Emissions here. I'm charging two 3-cell lithium polymer batteries in series. These are wired in series, which means the negative of one battery is connected to the positive of the other battery, and then the two remaining, the one positive here and the one negative, so one positive out of one battery and one negative out of the other battery, that's going to give the voltage of adding up the two cells. There's two 3-cells, so it makes it a 6-cell, which is approximately 25 volts fully charged. I think it's 25.2 volts at 4.2 volts per cell. So 4.2 times 6 would give us our number, which I think is 25.2, but please double check that. Why am I using what I'm going to call, and you have to research this for yourself, high voltage pulses to charge these batteries? Why would I do that? It takes longer, so this has been charging for 24 hours to increase approximately 1.5 volts, or 1.6 volts. To increase 1.6 volts, it's taken approximately 24 hours. So if it takes that long to charge, why would I do that? I'm studying the possibility and the reality, the real possibility and the reality of a battery having an infinite cycle life, and that's any battery. Now there may be one or two batteries that resist that, but we're talking about like 99.999% of batteries out there right now to have an infinite lifespan. Now, I'm not saying it's going to do that. I'm saying I'm researching the possibility of that. And I'm also researching the reality of that, because I understand, my research and study has indicated, anything we can imagine is possible. How to make it work, that's gonna be as varied as there are humans on this planet. That's why everyone counts, and that's why collaboration is the best tool. So this here is a negative energy oscillator. Now I've also studied that any pulse is automatically negative energy. So the mystery might be like, what's negative energy? How do we make negative energy? Or how do we channel it, right? If we're channeling, are we channeling negative energy from the Dirac Sea? D-I-R-A-C-S-E-A, the ocean of energy. Where's energy coming from? Where's it going? And what's the process of what's actually taking place? I think particle physics will get us very close to what's actually happening, right? So, and consider particle physics just the beginning, not the end. So particle physics, do you think particle physics knows everything? Do you think in 1,000 years we'll have made no new discoveries? In 1,000,000 years we'll have made no new discoveries in particle physics? I don't think so. I think we're going to keep learning, and I think there's a lot to learn. So I'm using this, but if someone just wants to use high voltage pulses with extremely low current or almost no current, you could experiment with that if you don't want to buy one of these. RCOS, negative energy oscillator. So what I'm doing is I'm powering this with this power supply here, which is made for, I think, a plasma globe. I think that's like 12 volts at half an amp. No, I think it's 12 volts at 350 milliamps, approximately. That's an approximation, but it's within specification of what this is requesting. This is saying it wants a 1 to 15 volt input and a half an amp max at half an amp. Then it says turn down dial for higher voltages, which sounds like we can go higher voltage. I connected this I was going to charge, I think it was an 84 volt battery, and this melted. So that was too high of something to connect it to, meaning connect it to charge it, right? Not on the input side. On the input side, I was just putting the same thing, right? It's very low input, what it's asking for. It's just the output, I was higher voltages. See, it says charges 1 to 48 volt batteries, but I wasn't sure if it can go higher than that. It says, oh, it says or higher depending on input. I didn't know if that meant if I put more input that I can go more output. If I go less input, I can go more output. I don't know. So I was trying to find those parameters, and this thing smoked. And So anyway, this is now full. I'm going to go ahead and turn it off by doing this. What do we do first? We turn off the power going to it. So I'll turn off the power. Okay, the light went out. And I'll disconnect the input. Output still connected. I'm disconnecting the input. This has to always be connected to a load and before being powered, okay? So that's extremely important. If there's no load on it, it can burn this up. So I always turn off the power first, going in, and then I can disconnect the power coming out. So this is just the meter, for the meter, and then this is the actual output. There it is. So this is now charged, and these batteries were actually not, when I first started using these, they were puffed up and worn out. And I've been charging it with this for a couple of years now, and it seems like the capacity is increasing because I run my Tiny's LEDs lights on the scooter, and I use this also for various different loads, and it's just, they're doing well. So the batteries are doing well, but like I said, it takes time to charge. So if you want to invent something new, maybe you could work on something that brings back the life of batteries, but faster than charging it so slow. Or just make variations of this, right? And do we actually invent anything, or do we just kind of rearrange things, knowledge we already have in imagination, bring it together to make something, do something that we're familiar with in an unfamiliar way, right? So you can give your own words to that idea. It's just the idea of how many different ways can we charge a battery. That's one idea, right? That's one way of saying it. Okay, everyone, True Zero Emission signing off, and this has been working very well for me, and I do recommend it. I think everyone should get one of these, and they're available on this website right here, Renaissance Charge, or go to Rick Friedrich YouTube channel and start experimenting today. Bye, everyone.